Hi everyone and welcome to Metallurgy with Marina. Today we're going to be talking about a DTR up at the University of Utah. Now you may be wondering, hey Marina, what's DTR? DTR stands for drop tube reactor, and it gets its name because of the tube that goes down the middle of the reactor. There are silicon carbon plates on each side of the reactor that heat up the reactor to 1300 degrees Celsius. Now you may be thinking, oh I know, hot. It's 100 degrees Fahrenheit outside. Well, that is true. However, we're talking very, very hot. And as I said, 1300 degrees Celsius. It gives you a bit of an input. Venus is about 475 degrees Celsius, and it is the hottest planet in the solar system. Then there's the sun. The sun's about 5500 degrees Celsius. So 5500 degrees Celsius versus 1300 degrees Celsius, that's about a fourth of the heat of the sun. In the drop tube reactor, we're going to be working with creating zinc ferrite to be able to mimic an electric arc furnace. An electric arc furnace is used for making steel. So we will melt down scrap material into a slag, so it's kind of a molten metal, to be able to refine it and purify it and use it to create steel. Now, a DTR is used at the university level to be able to mimic and create what an electric arc furnace is in industry. So in our drop tube reactor, we have that tube down the center where the gases are able to go and enter, along with hematite and magnetite. Now, hematite and magnetite are combinations of iron and oxygen. They go inside of that reactor. They stay in the reactor at 1300 degrees Celsius for around 30 minutes, and then afterwards, we create zinc ferrite. At the end of our reaction, though, we have off gases, and they are released, and they go into a scrubber and a cleaner. And then we have that collection bin where our zinc ferrite is collected. So you might be thinking, okay, what is zinc ferrite used for? So zinc ferrite is actually used for pigments. That's pigmentations in different colors, different paints, different materials, but it can also be kind of a con. So at industry level, zinc ferrite, they might not be wanting to create pigments. They're just wanting to create steel. So the zinc ferrite can actually cause a bit of problems with their dust and recycling. So if we can lower the amount of zinc ferrite in our industry, we can actually improve our world today as we know it. So John Otero is up at the University of Utah today, right now, working on lowering the amount of zinc ferrite in our electric arc furnaces for industry by using the DTR, which is the drop tube reactor. So I'm going to go ahead and turn the time over to John, and I hope you enjoy it.
Hey, hello everyone. I'm John Otero. I come from Chile. I'm studying my bachelor's degree in Pontifical Catholic University of Chile. Then I went to France to do a double degree program, and then I applied to the University of Utah to work with distinguished Professor Sohn. This is a drop tube reactor, also called DTR, that allows us to study can be the iron making and the zinc ferrite formation that supply the gases to the flow meters, in which we can measure the flow rates that will go to the reactor. So here we have a two-powder feeding system that will have vibration, and also we supply the powder with nitrogen into the upper flange of this reactor. So what we'll have in the upper part, we'll have CO2, nitrogen, also can be hydrogen, and we'll have the powders that can be hematite or magnetite, and by the chemical reaction of zinc, CO2, and hematite, which is the Fe2O3, iron and oxygen, right? Then we will have the zinc ferrite formation with CO. So then this chemical reaction will occur inside the alumina tube along with the heating elements that are supplying the heat for this chemical reaction to occur. So what we'll have in the products, we'll have the powders and the gases that goes out of this with filter and scrubber, and the powders can be collected. So with these operational conditions, will allow to determine where, when, and how the zinc ferrite is formed in the big industry, which can be the contribution for avoiding its formation that is harmful for the industry.
everyone, and welcome back from John's lab. I hope you learned a few things about the DTR, and just at the end of this video, I'd like to do a bit of conclusion of what we learned today. So first, we learned what a DTR is. DTR stands for drop tube reactor. It gets its name because of the tube that goes down the center of the reactor, where the hematite and magnetite in this case go in, react with the zinc and the carbon dioxide or hydrogen and nitrogen gas to create the zinc ferrite and carbon monoxide. The carbon monoxide then goes to the off gas outlet to be able to get cleaned and scrubbed. And then our collection bins are what collects the zinc ferrite. Now, zinc ferrite can commonly be used for pigments in things like paint. So right here, I have a bottle of spray paint. Or in the steel industry, it can kind of be a bit of a burden. So we want to be able to lower the amount of zinc ferrite that we are producing. And because of research like John's, we're able to do that. So DTRs are really neat because we can mimic what's happening in an electric arc furnace in the steel industry. Again, I thank you so much for watching this video. I hope you enjoyed it. I hope you learned a few things about it. If you could please like and subscribe to our channel, I would really appreciate it, and continue watching our videos. And also, if you have Facebook, Instagram, or TikTok, please go and follow @metallurgywithmarina. It would mean so much to me, and I'll make sure to go and follow you back. Thank you so much again, and have a great day.